Today we're going to talk about Lesson 5-3, rates. The big idea is the quotient of two measures with different units is a rate. Okay? For instance, price per night is a rate. Okay? You buy a hotel, price per night. Okay? Miles per hour on your car is a rate. Okay? These are two different units. Price, night. Miles, hour. Okay? That's the quotient of two measures with different units. Price, night, miles per hour. Okay? What is a rate? In Lesson 5-2, 32 ounces of orange juice were split evenly among 5 people. By doing the division with the units left in, we see that the answer is a rate. 32 ounces divided by 5 people equals 6.4 ounces per person of orange juice that they get. Every rate consists of a number and a rate unit. You may see rate units expressed using a slash or a horizontal bar. The slash and the bar are read per or for each. The rate unit, ounces per person, is read ounces per person. Okay? Not ounces divided by person. All right? In general, a rate is the quotient of two quantities with different units. Okay? In this case, it was ounces per person. Example 1 says, Tanya and Gary drove 400 miles in 8 hours during a trip. What was their average speed? Okay? Now I'm just going to show you the solution to this. What was their average speed? Well, they went 400 miles in 8 hours. Okay? It says divide the distance in miles by the time in hours. And I normally always like to use time on the bottom. Now, there's going to be certain cases where you need to use time on top, so that's why we're going to show you that as well. So, 400 miles per 8 hours. Well, 400 divided by 8 gives you 50 miles per hour. Okay? All you do is take this number, divide it by this number, leave your labels on, miles per hour. You could also divide time by distance. It just doesn't look very good because when we say hour per mile, it just doesn't sound that great. So, 8 hours could go on top, divided by 400 miles, okay, equals 8 divided by 400. Notice this is not going to be the same answer because 8 divided by 400 is not the same thing as 400 divided by 8. 8 divided by 400 gives you 1/50th hour per mile. So this means that on average it took them 1/50th of an hour to travel each mile. Okay? Now you can go figure out what 1/50th of an hour is. Okay? 60 divided by 50, which you can do on your calculator. 60 divided by 50, because 1/50th of an hour, 1/50th times 60 minutes is what I'm doing, gives you 1.2, okay? 1.2 hours it took them to go a mile. Quite a long time, right? In example 1, the first solution gives the rate in miles per hour. The second solution gives the rate in hours per mile, or how long it takes to travel 1 mile. These are reciprocal rates. Notice that 1/50th of an hour is 1/50th times 60 minutes, or what is 1.2 minutes. In other words, it takes a little over a minute to go 1 mile. Either rate is correct. The one to use depends on the situation in which to use it. Okay? Rates and negative numbers. Rates can be positive or negative quantities. Example 2 says, If the temperature rises from 70 to 85 degrees in 2 hours, what is the change in temperature in degrees per hour? So this is the formula that I use, okay? I say now minus before divided by time. Now minus before divided by time. So if you look at this, this is what it was before. This is what it is now. That's my time. This is what it was before. This is my now. This is how much time. So when you follow this method, you don't have to worry about, excuse me, is it positive, is it negative? Because when you do your math, it's going to come out positive or negative. So A, what is my now? My now is 85 minus my before. My before is 70 divided by time, which is 2. Well, we have to do what's on top first. 80 minus 70 is 10 divided by 2. And these are degrees. This is an hour. So 10 degrees per 2 hours. So you get out 5 degrees an hour or per hour. Okay? It's as simple as that. So B, 32 minus 44 divided by 5. 32 minus 44 is a negative 12 divided by 5 equals, okay, a negative divided by a positive, 2.4 degrees per hour. And notice, since this one went up from 70 to 85, it was positive in degrees. Since this one went down from 44 to 32, this ended up in negative 2.4 degrees. Okay? So, now minus before divided by time will help you get the answer that you were looking for. Okay? Moving on. Find the rate of change of the number of people at a restaurant if it decreased from 161 to 98 people in 45 minutes. Well, here's my before. Here's my now. We didn't have to have them tell us that it decreased. We can see it, 161 to 98. This is my time. Okay? So, 98 minus 161 divided by 45. So 98 minus 161 is a negative 63 divided by 45. It's going to give me a negative 1.4, okay? And that is people. And what did we divide it by? Well, we divided it by minutes. So they lost almost 1.5 people per minute. Okay? Negative fractions. It says in general, for all A and B cannot equal 0, negative A over B is equal to negative A over B, which is also equal to A over a negative B. Now what happens for Mr. Johnson is he just likes to keep that negative sign up in the numerator. Sorry. I like it up there. I don't like it down in the bottom, but sometimes when you're dealing with these rates, you're going to get it to be that way. Okay? It's the nature of the beast. Just remember, one negative makes it negative. If you put two negatives in there, so if you put a negative on this A and a negative on this B, Now it became positive and it messed up your whole problem. All right? Need to put that in your notes. Division by zero and rates. Consider the rate 0 meters per 10 seconds, which has 0 in the numerator. This means you do not travel at all in 10 seconds. Is that possible? Yeah. We can go 0 meters per second. Mr. Johnson's been sitting in this chair now for 10 minutes. Okay? He's went 0 meters in a numerous amount of seconds. Okay? So your rate is 0 meters per second. This reinforces that 0 divided by 10 still equals 0. In contrast, try to imagine a rate such as 10 meters in 0 seconds. Okay? Can I go 10 meters without any time elapsing? Not a chance. This has 0 in the denominator. This means you would travel 10 meters in 0 seconds, and for this to occur, you would have to be in 2 places at the same time. This is impossible, which also helps us with why 0 in the denominator is undefined and why it can never be 0. When a fraction has a variable in its denominator, then the expression is said to be undefined for any value of the variable that would make the denominator 0. So we always got to remember that. 0 cannot be in the denominator. Example 3. For what values of x is x divided by x plus 4 undefined? So what they are saying is, and this is what you need to pay attention because this is what a lot of people get mixed up on. They want to know what in here will make this undefined. Well, it's undefined if 0 is in the denominator. So what you need to do when they ask you that, you take the denominator, x plus 4, and set it equal to 0. This is what you need to write down, people. If you want it to be undefined, set the denominator equal to 0. Everybody has problems with this. I don't want you to. Go back and rewatch this after I get done. Okay? If you want to know when it's going to be undefined, set the denominator equal to 0 and solve. So, the inverse of adding 4, subtracting 4. Whatever I do on one side, I do on the other. X has to equal a negative 4. So when x equals a negative 4, this problem is undefined. So let's look at B. For what values of x does x divided by x plus 4 equal 0? Well, when you want it to equal 0, set the numerator equal to 0 and solve. So in this case, my numerator is x. I set it equal to 0. Well, if you look at this, x is already solved for itself. So when x is 0, we are going to get 0 on the numerator. So where we're going to get 0 at is when x equals 0. What's the values when this is going to be undefined? The only value of it's going to be undefined is at x equals a negative 4. Please rewatch that again. So let's look at quiz yourself 2. A, for what values of k is 2k minus 6 divided by k minus 55 undefined? Undefined means set the denominator equal to 0. So k minus, not equals, 55 equals 0. Well, what value of k would make this equal to 0? Well, if I add 55, k equals 55 would make my denominator 0, which means that would be undefined. So there's A. B says, for what values of k would make that expression equal to 0? Well, now I got to set my numerator equal to 0. So 2k minus 6 is equal to 0. So solve for k. It's just a two-step problem. The inverse of subtracting 6, adding 6. 2k equals 6 divided by 2, and k is going to equal 3. Okay? So when k is 3, that numerator is 0, therefore the whole thing is going to equal 0. Please pay attention to those last two examples. They're very important. That's what a lot of people get messed up on. Who knows? Mr. Johnson might allow you to use your notes on your test. That's all I have for today. Please enjoy. We'll see you tomorrow.